Hello again, all you fabulous Ford students. Mr. Pierce here again. I want to talk to you today about plate tectonics. So our learning goals for today, by the end of this lesson, you should be able to describe the historic development of evidence that supports plate tectonic theory, and you should be able to relate plate tectonics to the formation of crustal features. So first off, let's start off with Alfred Wegener. Wegener was a scientist who noticed that the puzzle-like fit of all the continents. And he said that all the continents were once one big continent called Pangaea. And he collected fossil evidence to support this. And what he found all sorts of interesting fossil evidence, which you'll be learning about a little bit more in depth in class. But he also found matching rock structures. So he found matching rock structures in South America and Africa that matched up. He found fossils that he found in South America and Africa. So he found lots of interesting fossil evidence. So he proposed the idea of continental drift in 1912, and basically he said that the continents once formed a large landmass called Pangaea that broke apart and drifted to their current locations. For 30 years, his theory was not accepted. It took a while until this guy named Harry Hess comes along. Harry Hess, he was a World War II ship captain whose real job outside the war, before the war, was a geology professor. And he would take a ship and cross the Atlantic, and one of the devices he had on the ship was a depth detector, and that they used it when they came in close to shore. Well, Hess, being the geologist, he decided as he was traveling across the Atlantic Ocean and across the oceans of the world, he would turn on his depth detector. And what he noticed as he got to the middle of the Atlantic, he noticed a large volcanic mountain range there on the ocean floor. So after his stint in the Navy during the World War II, he did some more research on this, and in 1958 he proposed the theory of seafloor spreading. And he said that the crust in the parts of the ocean is splitting apart, allowing magma to rise to the surface, forming new crust, and pushing the ocean floor apart. So that as magma rises right here, it pushes these two sides apart and spreads apart, and then new ocean floor is formed right here at this volcano. Now, evidence for this is supported by the Glamour Challenger. This is a ship that took samples of rocks across the Atlantic. So as it sailed across the Atlantic, it would drill a hole down into the seafloor and pull up rocks. And what it found that newer rocks were in the middle of the ocean, and as you got away from the middle, going towards the continents, the rocks got older. And this confirmed the idea of seafloor spreading. So we take Wegener's idea of continental drift and Hess's idea of seafloor spreading, and we kind of combine the two, and this gives us our theory of plate tectonics. And the theory of plate tectonics says that the Earth's crust is broken into several large tectonic plates that are in constant motion due to convection currents in the mantle. So we have these convection currents. We have the mantle. It's slowly moving around, and as it moves, it produces a current, kind of like out in the ocean. And we're up here on the crust, floating on top, and we're just going to move wherever the current carries us. And so the crust on top of the mantle is constantly moving due to these convection currents. So they move due to the convection currents in the mantle. They're constantly being pushed together, pulled apart, and they're sliding past each other. So wherever two of these plates or little boats that are floating, two pieces of crust, meet, we call this a plate boundary. The forces of the interaction of these plates cause breaks in Earth's rocks layers called faults. So we see here we have our major types of plate boundaries. We have a convergent boundary where plates are going to be coming together. We have divergent boundaries where plates are coming apart. We have, and we also have transform boundaries where the plates are sliding past each other. So we're going to go through and kind of talk about all these different boundaries right here. But first off, we talked about that as plates come up in contact, rub up against each other and whatnot, it's going to cause a break in the rock that we call a fault. Well, we have three types of faults. Our first one is a normal fault. And in this one, the rocks are being pulled apart. So we have rock being pulled away from each other. In a reverse fault, they're going to be coming towards each other. And then in a strike-slip fault, they're going to be sliding past each other. So here are all the plates that cover the Earth. We can see we got a lot of big ones. The Eurasian plate, the North American plate's a pretty big one. The Antarctic plate, we got the Pacific plate, African plate. So these are all different sections of the Earth's crust that are in constant motion, rubbing up against each other. Now at a divergent plate boundary, two plates are moving apart. We consider this to be a constructive force because it's going to be building new plates. We're going to be building new land. And so some of the features that we're going to see is a rift valley. And a rift valley is simply a tear in a continent. So if we have a divergent boundary on a continent, the Great Rift Valley in Africa is a great example of this. It rips the ground apart, tears it apart, and we're going to have kind of a feature where it's torn apart, and then it's going to eventually fill in with water, forming a shallow sea. And as it keeps on going and pulling apart, it might even form a brand new ocean. So this is going to be, rift valleys are going to be occurring on continents, on land. Down in the ocean where the crusts are being ripped apart, we call this a mid-ocean ridge. And this is a volcanic mountain range that forms on the seafloor, and it's what's responsible for seafloor spreading. And an example of this is the Mid-Atlantic Ridge. At a convergent boundary, two plates are converging or colliding, coming together. This is considered a destructive force because it's going to be destroying the plates. If we have convergent boundaries can form lots of different things. If we have two continents colliding, we're going to form mountain ranges. They're going to push up on each other and rise up into the sky. An example of this are the Himalayas. We could have a continental plate and an oceanic plate colliding, and in this case, one of the plates is going to slide down below the other and form what we call a subduction zone. And we'll look at some features of subduction zone. Some other common things that are going to be happening around convergent boundaries, we're going to have lots of volcanoes because we're destroying plates. Plates are getting sliding down into the earth, melting. That stuff's going to come back up as volcanoes. And earthquakes are pretty common in these areas as well. Now, a subduction zone is a special type of convergent boundary where dense oceanic crust moves down and sinks below the less dense continental crust. Now, as the oceanic crust dips down and goes down into the mantle, it's going to melt, and that melted material rises back to the surface, forming volcanoes. Where the two plates meet, a trench is formed, and because it's going to be bending down into the earth, and it's going to form a depression in the earth, and this is going to form a trench, or a deep sea trench. An example, we have the South America plate, or the Nazca plate. So South America is colliding into the Pacific Ocean plate, or the Pacific plate, and the Pacific plate's dipping down and forms a big, huge trench along South America, off the coast of South America. And we also should know that South America has lots of volcanoes along that area. So this is what's happening in a subduction zone. We have the oceanic plate being pushed down. As it pushes down, it forms a slight depression right here, forming a deep sea trench out in the ocean. As it dips down, this plate melts. That material rises back up to the surface, forming volcanoes. So if this is the Pacific plate, here we have South American plate. They're coming together, colliding. The Pacific plate dips down. Magma rises to the surface from this melted plate, forming the Andes Mountains. Another thing that can form if we have two oceanic plates colliding are a set of islands called arc islands. This is where one oceanic plate slides under another one at a convergent boundary. It forms a line of islands at the plate boundary, and examples are the Aleutian Islands and the Antilles. The Aleutian Islands are the little string of islands that come off of Alaska, and the Antilles are basically, we can think of those are islands in the Bahamas, out in the Caribbean. And these are all formed from two plates colliding. Our last boundary is a transform boundary. This is called a conservative force because we're not destroying or constructing any new plates. And the two plates are simply sliding past each other. Some of the very common features here is that we're going to be forming faults, things like the San Andreas Fault and we probably know the San Andreas Fault is very famous for having earthquakes. So we're going to have major earthquakes along fault lines here at transform boundaries. So the slates are just slowly sliding past each other. Another interesting feature is another constructive force is called a hotspot. Hotspots are found at certain points around the Earth, and basically nobody can quite tell us why, but hot mantle from deep within the interior of the Earth is rising up, and it burns a hole through the crust. And this is going to be a volcanic region as mantle is rising up, and they're not located on any plate boundaries. An example of these, the Hawaiian Islands, are formed on a hotspot. Hotspots are great at showing us how plates are moving because the hotspot stays in one spot, but the plate moves over it. And we have a chain of islands like the Hawaiian Islands here. Yellowstone National Park sits upon a hotspot. It's actually a Old Faithful and all that. Those are all related to magma down deep in the crust formed from this hotspot. And the Galapagos Islands are also on a hotspot. Hope you learned a little bit about plate tectonics today. Thank you very much.